Welcome to this tutorial on Nullspace EM, a fast, direct, and highly accurate solver ideal for large-scale electromagnetic analysis and design. This video is designed to enhance the onboarding of new Nullspace EM users by walking through an example demonstrating the Nullspace EM simulation workflow. This example is also included in the Getting Started section of the Nullspace EM user guide. Before starting this tutorial, please verify that Nullspace EM is properly installed using the guidance provided in the installation instructions. Once Nullspace EM has been installed, we can add the default location of the software to our path environment variable for convenience. In the video, we are assuming that Nullspace EM has been installed in the default location. For our Getting Started example, we will be examining the bistatic radar cross-section of a perfect electrically conducting sphere with a radius of 0.5 meter at a frequency of 300 MHz. All of our resources to execute this example will be created and stored in a designated working directory, which we will name Simple PEC Sphere. After creating the directory, we can launch Nullspace Prep, a comprehensive CAD and high-order meshing preprocessor, part of the suite of Nullspace software products. Once it opens, we can set our working directory within Nullspace Prep for ease of use. With Nullspace Prep, CAD can be created using the GUI, editing a journal file, or utilizing a Python API. For this example, we will showcase the journal file capability of Nullspace Prep. This journal file contains the Nullspace Prep command syntax required to generate the PEC sphere. The journal file provides the commands to generate a high-quality mesh for our analysis frequency of 300 MHz. Pressing play runs the journal file, generates the CAD and mesh, and exports the simulation-ready meshed object to our working directory. Once the object has been created, we can generate the Python script that creates the Nullspace EM simulation model and produces the report of far-field bistatic RCS values at a set of observed angles. This script allows both simulations and reports to be executed from the Python API. Now that the mesh has been created and the simulation script is complete, we can execute Nullspace EM. Nullspace EM's Python API gives users the advantage of post-processing simulation data for any purpose, utilizing the full capability of the Python programming language. In this example, we've generated a script to access the far field's data and return the full set of RCS data in spherical polarization for visualization of the object's RCS for both co-polarized results. For further reference, this full example is available in the examples directory of your Nullspace EM simulation installation. Nullspace EM, built for engineers by engineers. Thank you for watching this video, and check out our YouTube channel for more helpful tutorials, webinars, and demonstrations.